All right, question 3 says consider the system y is x squared minus 3x plus 4 and y equals negative x squared plus 6x. So describe the shape of each curve in the system. Well, we have now two quadratic equations. So this is quadratic and this is quadratic, telling us that the graphs of these equations are parabolas. So now we're looking for where these two parabolas are going to intersect. And so for B, okay, we're going to solve the system. And so in exactly the same way we've solved the others, okay, I'm going to go ahead and just replace y in equation 2 with this expression that I get from equation 1 for y, right? So I'm just going to put in x squared minus 3x plus 4, and that's going to equal minus x squared plus 6x. So we have quadratic equations, so I'll go ahead and solve by adding x squared to both sides and subtracting 6x from both sides. All right, so this is going to give us 2x squared, then minus 9x, and then plus 4 on the left, and a 0 on the right. And so here I can factor this, fortunately. So need a 2x and x here. And for the 4, I'm going to put a 4 here because this is going to give me an 8x, and then a 1 here. That's going to give me an x. So if I put minus signs in each binomial, I'll get minus 2x minus x. Yeah, that's minus 9x. And then a minus 1 times a minus 4 is a positive 4. So that works. All right, now let's set each factor to 0. So if 2x minus 1 is equal to 0, then if I add 1 and then divide by 2, I get that x is equal to a half. And if x minus 4 is 0, then x is equal to 4. Okay. So here are the two x values. So then, just like the other problems, we need to then go find the corresponding y values. I got to do that for both of these values of x. So starting with x equals a half, well, I can plug half in for x in either equation 1 or 2. I'll go ahead and use equation 2. It's maybe slightly simpler. All right, so I'm going to get that y is equal to minus 1/2 quantity squared, and then I'm going to add 6 times a half to that result. So this is minus a quarter, and 6 times a half is 3. And now common denominator, it's minus a quarter plus 12 quarters. So this is 11 quarters. All right. So this gives us the ordered pair 1/2 for x and 11 fourths here for y. Okay. And then for x equals 4, you can do that down here. We'll go ahead and again just plug in to equation 2. So we get that y is equal to negative 4 squared plus 6 times 4. And so here, this is a negative 16 plus 24, and that is a positive 8. Okay, so This gives us the ordered pair solution 4, 8. All right. And then there's a part C for this question, and this says, find the equation of the line that passes through the points of intersection for these two curves. Well, what we just found is that the points of intersection are right here, right? 1/2, 11/4 and 4, 8. So to find the line that passes through these 2 points, let's go ahead and first we'll find the slope. And so I have the point 1/2 and 11/4, and then the point 4, 8. So for our slope, well, how much is x going up? We're going from 1/2 to 4, so that's an increase of 3.5 or 7/2 as a fraction. And then for the y, we're going from 11/4 up to 8. And so, well, let's see here, a little bit messier, but what is 8 in terms of fourths? That's 32/4. So going from 11/4 up to 32/4, that's an increase of 21/4. All right, so now let's go ahead and find the slope by dividing the rise and the runs. So here our m is the ratio of 21/4. That's the rise to the run, which is 7/2. And then I can go ahead and multiply 21/4 by the reciprocal of 7/2 to simplify. So this is 21/4 times 2/7. And so here, notice we can divide out a factor of 7. So 21 divided by 7 is 3, and 7 divided by itself is 1. And then here I have a 2 and a 4, so I can divide out a factor of 2. That's going to give us a 1 here and a 2 here. So when all is said and done, we get a slope of 3/2. All right, now I'm going to just make a little space here. So we get that m is 3/2, so that's telling us now that our equation for the line that passes through these 2 points of intersection looks like this. Y is equal to 3/2 x plus b, the y-intercept, right? So the last thing we need to do now is find the value of b. So let's do that here. And I can plug in the coordinates of either this point in green, right, 1/2, 11/4, or this point in red, 4, 8. I'm definitely going to go with red here because of the fact that the coordinates are whole numbers. So I'll go ahead and plug in 4 for x and 8 for y. And let's see what that gives us. Well, we'll get an 8 on the left, and that's equal to 3/2 times x, which is 4. And then that's going to give us, and then I'm adding b there. So that's going to give us what? Well, 3/2 times 4. If I divide 4 by 2, I get 2, and 2 times 3 is 6. So I get that 8 is equal to 6 plus b. And now if I just subtract 6 from both sides, I can see that b is equal to 2. All right, so now putting that all together, our equation for part C is y is equal to m, which we found here is 3/2 x plus b, which we just computed to be 2. Okay, so this is the line that passes through these 2 points of intersection for these 2 parabolas. Let's go to the graph here. We have our parabola here, y is x squared minus 3x plus 4. That's equation 1 in red. For blue, this is y is negative x squared plus 6x. That's equation 2. And then let's check the points of intersection. 4, 8. Yep, looks good. And 1/2, comma, 2.75. And 2.75 is 11/4, as we found. All right, so that's all good. And then lastly, put in the equation of the line we computed for the line of intersection. And that's y is 3/2 x plus 2. And yep, it passes right through those 2 points of intersection. So it works. All right, thanks so much.